Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the HTTP host header attacks module titled Routing-Based SSRF. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs and do a search on the host header, attacks labs, and select lab number 4 titled Routing-Based SSRF. Alright, let's get started. This lab is vulnerable to routing-based SSRF via the host header. You can exploit this to access an insecure intranet admin panel located on an internal IP address. To solve the lab, access the internal admin panel located in this range over here, then delete the user Carlos. We also have a note that says to prevent the Academy platform from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. To solve the lab, you must use Burp Collaborator's default public server. So the vulnerable parameter over here is the host header, and the goal is to exploit the host header injection in order to perform an SSRF attack to access the admin panel that is available on an internal IP address in this range, and then delete the user Carlos. Alright, let's access the lab. Now notice over here that I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Since we are performing an SSRF attack, you will need the professional version of Burp in order to perform all the functionalities that I'm going to perform in this lab. However, to complete the exercise, you don't need the professional version. You could just use the community edition. The only portion that the professional version is used for is to check if an SSRF vulnerability exists, where we use the collaborator module. However, again, it's not necessary to complete the exercise, and so you could just watch this step and skip it and then complete the remaining exercise using the community edition. All right, first thing we're going to do is click on Home and then send that request to Repeater. Let's send it to Repeater. Now, in the previous labs, we looked at many different attack vectors when it comes to host-based header injection. One specific attack vector that you can perform when you have host-based header injection is server-side request forgery. This specific attack vector occurs when the traffic between the client and the backend servers is routed through an intermediary system, such as a load balancer or a reverse proxy. So all the domain names for the website end up resolving to a single IP address of that intermediary system. So in this scenario, the host header is usually relied on to know that this specific domain resolves to this specific website in the backend. Now, vulnerabilities may occur in this functionality if the value of the host header is not handled in a safe way. So if the server implicitly trusts the host header and fails to validate it properly, then an attacker can enter malicious input as the value of that header. And one attack vector that you can perform if you have this vulnerability is, like I said, server-side request forgery, or in short, SSRF. We have an entire module on this topic, so if you're not familiar with it, make sure to check it out. But at a high-level overview, server-side request forgery is a vulnerability that allows an attacker to cause the server-side application to make requests to unintended locations. So this can be an external server, such as an attacker-controlled server. And that's why in the note over here, it says, in order to prevent the Academy from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. So that's a specific scenario where you would use the application in order to perform requests to third-party systems, and that's why they have firewall rules in this specific lab. We'll see an example of that when we check for SSRF with the collaborator functionality. But another attack vector is where you use this SSRF vulnerability in order to access internal servers on the internal network. So you've got the application right over here. So the client application, which is what you're seeing in the browser. Now that's hosted on an application server in the internal network. And let's assume this over here is the firewall rules that prevent you from accessing the application server. Now, in that internal network, you could have many other servers. So you could have server 1, server 2, server 3, and so on. Now, if I'm an attacker and from the outside I try to access server 1 or server 2 or server 3, I'm not going to be able to because there are firewall rules that prevent me from accessing these servers. However, with an SSRF vulnerability, what you do is you exploit this vulnerability in order to access an internal server such as server 1 through the application server. Now, since they're both hosted in the internal network, that trust relationship allows you to access those servers. And that's exactly what we're going to do in this lab. We're first going to perform an IP scan to determine where these servers exist within this range over here. And then from there, we're going to find an HTTP server, we're going to access the admin panel, and we're going to delete the Carlos user. But before we do that, we need to confirm that this application is vulnerable to host-based header injection and to an SSRF vulnerability. And the way to do that is using the collaborator functionality, which again is only available in the professional version, I believe. So click on Get Started and then copy to clipboard. This gives us an external server that we can send our traffic to. From there, in Repeater, I'm going to put it in the host header. And if the host header accepts any arbitrary value, then I should get a ping back to my collaborator server. So if I hit send, right away, I see that it displays the page for this specific external server. So right away, I already know that it's vulnerable to SSRF and host-based header injection. But to confirm, like you click over here and you automatically see just the value of or the page that this resolves to. So if you go to collaborator right over here and click on poll now, you see that we get two pingbacks. The first one is from the application server that this website over here is hosted on. So that would be this right over here. So we're already gained access to the internal network. And then the second pingback was from our own server when we loaded the page right over here. So we've confirmed that this is vulnerable to SSRF and to host header injection. So we're going to send this to intruder in order to perform an IP scan. Now we know that there might be other servers on the network. We just don't know which IP they're hosted on. And so we're going to perform an IP scan in order to determine where that HTTP server is hosted. So to do that, we'll get the range that we were given in the lab, 192.168.0.0. So that starts off from 1 up until 254. So we're going to click on add payload right over here and then go to payloads, and then from there select numbers and go from 1 to 254. And the step count is 1, which means that it increases by 1 every time. So it'll start off with 192.168.0.1, and then it'll do .2, and then .3, and then .4 up until 254. Now, another important thing you need to do is remove this check mark over here that says update the host header to match the target, because we don't want the host header to match the target over here. We need to make sure that it's doing an IP scan. So we're going to click on Start Attack, click Ignore. And if you're using the Community Edition to perform this attack, it's going to be much slower than the professional version because the Community Edition is heavily throttled. So what I'm looking for is a different status code or a different length for the request than the one that I have for this IP address over here, because this IP address clearly doesn't host an internal server. And so let's reorder on this. And right away, I see one of the IP addresses gives me a 302, which means that this IP address is likely to be valid. Let's copy it. And then in the response over here, it says /admin panel. So it redirects me, that's the 302, to the admin panel, which means that we've identified the server that has an HTTP application on it. So let's say server 1. We've identified the IP address for server 1. So we're going to use this application server in order to access this server over here, because there is a trust relationship between the two. And since they're both under the internal network, it may not require authentication in order to access the admin panel, which is really bad security practice. However, I've seen it happen many, many times in organizations because they assume the internal network is completely safe, which you should assume compromise. You should definitely not assume that the internal network is safe. So what we're going to do over here is change the host to the IP address that we've identified, hit send. Again, we get a 302 to /admin, so we're going to go to the admin page. And here we go. When we click on render, it looks like it's not rendering properly, so let's right click and click on request in browser, current browser session, copy and paste over here. And right away, it looks like we do have access to some kind of HTTP server. It takes in any username and it allows us to delete that user. So I'm going to perform the request over here. It's not going to work because we're performing it from an external perspective, not from an internal perspective. However, that's fine because all I need is the structure of the request, and then from there I'll just change the host header to exploit the SSRF vulnerability once again in order for me to be able to delete the user. So if we go back and get the IP address, paste it in here, it should work because there is a trust relationship between these two servers. So hit send and we get a 302 confirming that the user was likely deleted. So if we load this again, you could see it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the host header-based injection vulnerability in order to perform an SSRF attack. In the next lab, we'll look at another attack vector that you can perform when you have a host header-based injection.